Not all acids are created equal. There are 6 strong acids that dissociate completely in solution and have the lowest pH. But what about the other acids? The weak acids that don't dissociate completely. How do we compare their strength? In order to rank the acids, we need to look at the stability of the conjugate base. The more stable the conjugate base, the more likely the acid will want to lose the proton to go to that stable state.
We use SERHI to determine the stability of an acid's conjugate base.
SERHI stands for the order of traits that determine conjugate base strength: size, electronegativity, resonance, hybridization, and induction. Size is most important in determining acid strength. The larger the atom, the more stable the conjugate base. This is because the larger atom is better at diffusing and spreading out the negative charge. For example, when you compare nitrogen to chlorine, chlorine is significantly larger and can spread the negative charge better across the whole thing. The more electronegative the atom, the stronger the acid and the more stable the conjugate base, because the more electronegative atoms are more hungry for electrons, and it will be happier with more electrons or a negative charge than an atom that is less electronegative. The more resonance structures a molecule has, the more stable it is. When the negative charge can be delocalized through resonance, the molecule is stable and happy because the charge does not stay in one spot. Atoms that have hybridization with greater S character are lower energy, and a lower energy state molecule has greater stability. Electrons with s orbitals are closer to the nucleus because s orbitals are spherical and more compact than p orbitals, which makes them lower energy. Electronegative atoms can create induction, which makes a molecule more stable. Electronegative atoms can draw negative charge away from unstable atoms and towards themselves, effectively spreading the electron density across the entire molecule, which leads to considerable stabilization of the conjugate bases.
In addition to strengthening acids, stable molecules or atoms make for good leaving groups. Good leaving groups are usually weak bases because they are happy and stable on their own. Some examples of weak bases are halide ions, like iodine, bromine, and chlorine. On the other hand, strong bases are bad leaving groups. This is why alcohols don't participate in SN2 reactions very much.